Good evening, students. I hope you are all ready to start with the chapter Solution of Triangles. So, let me introduce you what we'll be gonna do today. We will be going to do the first three things, that is the sine rule, cosine rule, and projection rule. And tomorrow we'll be doing the next three things, that is half angle, Heron's formula, and Napier's analogy. Got it? So here, let's start with sine rule. You all must be knowing what is sine rule. Correct? So what is sine rule? Sine rule is basically A upon sine A is equals to B upon sine B is equals to C upon sine C. Correct? Is equals to 2R. We generally don't use 2R. Basically, we use lambda. Now, how to use sine rule? If I equate first and last, then I'll get A is equals to lambda times sine A. Similarly, I'll get B equals to lambda times sine B. And lastly, I'll get sine C. And if you see the second one, this one, if I equate this, I'll get sine A is equals to Ka. Sine B is equals to Kb. And sine C is equals to Kc. Now, the most important thing here is how sine rule helps. How sine rule helps. So sine rule helps me to do two things. First is convert angles to sides. Converts angles to side. And second, converts sides to angles. By using this, I can convert sides to angles. By using this, I can convert angle to sides. So this is the use of sine rule. So whenever in questions where we have proved that, someone asks me if I have to prove from side to angle, I can use sine rule. Now let's look at the question to see what am I talking about. So here, this one. In triangle ABC, angle A is given 30 degree, angle B is given 60 degree. So we all know that A plus B plus C is 180 degree in a triangle, correct? So that means 30 plus 60 plus C is equals to 180 degrees. What does this mean? This means C is equals to 90 degrees. Simple. But we have to find ratio of sides. So we know that by sine rule, I can write A equals to lambda sine A, which is 30 degree, which is lambda into half. Second, what I can write it B as lambda into sine B, which is 60 degree, which is lambda into root 3 by 2. And C is lambda into sine 90 degree. What is sine 90 degree? It is 1. So when I take a ratio, A is to B is to C. That means I'll get lambda into half is 2. Lambda into root 3 by 2 is 2. Lambda into 1. If I take LCM, or basically if I multiply throughout by 2, I'll get lambda is 2. Lambda root 3 is 2 lambda. Now similarly, I can divide by lambda. So I'll get 1 is to root 3 is to 2. That means A is to B is to C is 1 is to root 3 is to 2. Correct? So I hope it is clear. This was a very basic example to get sine rule. Now let's move on to the next, which is cosine rule. Second one is cosine rule. How does cosine rule helps us? As you can see, cosine rule helps us to convert angles to sides. Cosine rules helps us to convert angles to sides. Remember, sine rule helps us both ways, angles to sides and sides to angles. But cosine rule only helps us to convert angles to sides. There is one more form of cosine rule, that is, if I simplify this, if I get the value of a square from this first equation, I can write a square as b square plus c square minus cos A. We rarely second form, rarely. Most of the times we'll use the first form. Now let's see what you can write it b square as from second equation. I can write it b square as c square plus a square minus 2ca cos b. And similarly, I can write c square is equals to a square plus b square minus 2ab. So these three forms we rarely use. We basically use the first three forms. Got it? So let's look at this example. We are given sides and we are asked angles. That is, sides are given and angle is required. In such cases, I need to convert sides to angles. So what does this give us? Cosine rule. Obtuse angle means more than 90 degree. So I'll calculate cos A, I'll calculate cos B, I'll calculate cos C. If out of these three, any of one is negative. Why negative? Because obtuse angle means second quadrant and cos is negative in second quadrant. So if any of this is negative, then I can say that the triangle is obtuse angle. So let's calculate cos A. Do you remember cos A? Cos A was b square plus c square minus 2bc. That means 3 square plus 4 square minus 2 square upon 2 into 3 into 4. Correct, na? BC, right. So this means 9 plus 16 minus 4 upon 4 to the 12 to the 24. So this is positive. No need to calculate for it. It is positive. So cos ऐसे तो नहीं मिला. Let's look at cos B. Cos B क्या था? C square plus A square minus B square upon 2CA. So that means 4 square plus 2 square minus 3 square upon 2 into 4 into 2. 16 plus 4 minus 9 upon 4 to the 8 to the 16. So again, this से भी नहीं मिला. So basically, what we will have to calculate finally, उम्मीद है किस पे टिकी है? Cos C पे. Cos C is a square plus b square minus c square upon 2ab a square. So 2 square plus 3 square minus 4 square upon 2 into 2 into 3. This is 4 plus 9 minus 16 आ गया upon 2 to the 4. These are 12. So what is this? 9 plus 4, 13 minus 3 by 12, which is minus 1 by 4. I am not at all interested in the value. I am just interested in value negative. What does value negative I means? Cos C is negative. This means that C is obtuse. C is obtuse angle. And what does C is obtuse angle means? C is obtuse angle means that the triangle is obtuse angle triangle. Correct? Chalo. If it is clear, let's move on to the next question. Here. In triangle ABC, prove that. So if you can see, if you observe this, on the left hand side, we have angles and sides. On the right hand side, we have side. That means I don't need angles on the left hand side. If I am going to prove something, I don't need angles. Then I'll easily prove this. This means I need to convert angles to sides. And what better way to convert angles to sides other than cosine rule on LHS. The first I'll open the bracket. I'll get AB cos C minus AC cos B. That means I'll get AB cos C क्या था? Cos C क्या था? A square plus B square minus C square upon 2AB. AB और AB cancel. Minus AC. Cos C क्या? Cos B क्या था? A square plus C square minus B square upon 2AC. AC and AC got cancelled. Denominator में 2 is the LCM. So numerator में I'll be left with A square plus B square minus C square. Minus अंदर जाएगा तो सबका साइन चेंज. A square minus B square plus C square plus B square. A square cancelled बस. So ऊपर B square plus B square 2B square minus 2C square upon 2. If I take 2 common from this, it'll get cancelled. क्या मिलेगा? B square minus C square, which is equal to RHS. Hence proved. See, so simple. You just have to analyze कि left hand side में हम लोग के पास side है या angle, and right hand side में हम लोग के पास side है या angle. After you analyze this, it is very simple. Just convert side to angle by using sine rule or cosine. Now, do you remember the third one? What we are going to talk about in the third one? Third one क्या था? Sine rule था आज का aim, cosine rule था, और third one was projection rule. Now, projection rule basically, let me tell you how. Projection rule is basically a modification of cosine rule. Is modification of cosine rule. So if I know sine and cosine rule, I actually don't need projection rule. But बहुत बार क्या होता है, projection rule हम लोग को speed बढ़ा के देता है. That means कि अगर मुझे cosine rule use करके 2 पेज में आंसर आ रहा था, तो projection rule use करके 1 पेज में आएगा. Basically, projection rule is mainly to help us with the speed. Now let's check the proof. ये first वाले का मैं कर रहा हूँ. How to prove this? Very simple. RHS में you can see cos B and cos C. बस वहां पे हम लोग को क्या यूज करना है? Cosine rule. ये projection rule prove करने के लिए look at it as a proof. I have to prove LHS equal to RHS. RHS में क्या क्या था? भी था और साइड भी थी. So I need to get rid of angles because LHS में क्या है? Only sides. So RHS में मैंने cosine rule यूज किया. Cos C क्या था? A square plus B square minus C square upon 2AB plus C into cos B क्या था? A square plus C square minus B square upon 2AC. यहाँ से कैंसल. सो एलसीएम में क्या आया? 2A. ऊपर आएगा A स्क्वायर प्लस B स्क्वायर माइनस C स्क्वायर प्लस A स्क्वायर प्लस C स्क्वायर माइनस B स्क्वायर. C स्क्वायर कैंसल, B स्क्वायर कैंसल. I'll get A स्क्वायर प्लस A स्क्वायर 2A स्क्वायर अपॉन 2A. 2 cancel, 1A cancel, which is equal to A, which is equal to LHS. Hence proved. So it is very simple. But one thing I need to know कि how to click कि कोई question में I need to use projection rule. So what I do is I simply remember these formats. B cos C, C cos B. C cos A cos C. A cos B, B cos A. तो अगर क्वेश्चन में ये फॉर्मेट दिखती है, कौन सी फॉर्मेट, बी साइड है तो सी एंगल, बी कॉस सी कॉस बी, सी कॉस ए कॉस सी, और लास्ट कौन सा बचा, ए कॉस बी उल्टा बी कॉस ए. So if in a question I see this or see one of these, I can think of using projection rule. It is not compulsory to use a projection rule. As I told you, projection rule में खाली अपना speed बढ़ेगा, cosine rule और sine rule आता है, तो I can easily. It is important speed. Speed is very important in case of JEE mains. So let's look at this. Look at the patterns. So here. Now, can you guys notice any of the patterns in the before slide which I showed, in the previous slide which I showed? See, if I start with LHS, I have to prove that, right? This is equals to this. If I open the bracket, I see A cos C minus A cos B. Now, this is a very good hint. Why? A or cos C. A or cos B. To remember this, the projection rule, A or cos C, A and cos B. So this is the hint of using projection rule. So what was the projection rule? Let me write it. B was equal to A cos C plus C cos B. मुझे क्या चाहिए? A cos C. So यहाँ से I can write A cos C as B minus C cos B. Similarly, C was equal to A cos B plus B cos A. मुझे क्या चाहिए? A cos B. So यहाँ से implies A cos B is equals to C minus B cos A. If I substitute these two in LHS, what I'll get is B minus C cos B minus C minus B cos A. If I open the minus sign, B minus C cos B minus C plus B cos A. गड़बड़ कर लिया, I guess. A cos C. A cos C, yeah. So I can write it as from here and from here. I can take B common, I'll get 1 plus cos. And from these two, I can take C common, I'll get 1 plus cos B. Correct? कि कुछ गड़बड़ है? I guess we did a mistake somewhere. A cos B, C minus B cos A. A cos B, C minus B cos A cos C, B minus C cos B. Actually, here should be A, right? We made a mistake here. It is C cos A. Now it's correct. And it should be C cos A, na? A cos C, C cos A. C cos A. C cos A. So if I take common B, I'll get 1 plus cos A. Similarly, minus यहाँ से common लिया, क्या मिलेगा? 1 plus cos A. So if I take 1 plus cos A common, I'll get B minus C into 1 plus cos A. What is 1 plus cos A? It is 2 cos square A by 2. As you can see, which is equal to RHS. Hence proof. So this is a very good example of using projection rule. How do I click the projection rule? By seeing the pattern. A cos C, A cos B. Got it? Let's move on to the next question. This one. It is a very good question. Nice question. We can mark it as star. So, what can we do here? We'll either start with LHS or start with RHS. But let's analyze something. In LHS, we have angles. In RHS, we have sides and angles. I don't want sides. I only want angles. That means in RHS, I need to convert sides to angles. Sides to angles. And sides to angles implies which rule? Sine rule. Because cosine rule only gets me angles to sides. So let in RHS we use sine rule. So RHS में B को I can write lambda sine B minus lambda sine C upon lambda sine A. A by 2. I can take lambda common and cut. So I'll get sine B minus sine C upon sine A into cos A by 2. Now what is sine B minus sine C? Sine B minus sine C is factorization formula 2 cos addition B plus C upon 2 into sine subtraction B minus C upon 2 upon sine A. If I use half angle here, I can write 2 sine A by 2 into cos A by 2. And here it is already cos A by 2. So 2 gets cancelled, cos A by 2 gets cancelled. Now, since it is a triangle, I know that A plus B plus C is equals to pi. That means I can write B plus C by 2 as pi by 2 minus A by 2. That means I can, what do I want? Cos B plus C by 2. That means cos of B plus C by 2 will be equal to cos of pi by 2 minus A by 2. Now, do you know Allied angles? Cos of pi by 2 minus A by 2 is sine A by 2. So that means now, what will my LHS look like? In place of cos B minus C by 2, I can write sine A by 2. So my LHS will be sine A by 2 into sine B minus C by 2 upon sine A by 2. And you can see clearly this will get cancelled. So I'll be left with sine B minus C by 2, which is equal to LHS. Hence proved. So again, it becomes very simple if we just see the question in terms of angles and sides. Got it? Here we have to start with RHS. I'll give you 10 seconds to go through the question again. If you have any doubt, you can ask me. Otherwise, we'll proceed further. Okay? I'll give you 10 seconds. Come on, guys. Done? Okay, let's move forward to the next question. This is also a good question. See, how do we start the question? By analyzing. Let's look at left hand side. Left hand side, I have AC. That means I have sides and angles. Right hand side mein I have sides. So that means from left hand side I do not want angles. I need to convert angles to sides. But the problem here is the angles are in half, A by 2 and C by 2. But we in sine rule, cosine rule or projection rule do not know half angle formula. That means I need to convert A by 2 to A and C by 2 to C. That means I need to use the half angle formula. So if you know this, that is, what is 1 minus cos theta? It is 2 sine square theta by 2. I'll use this formula. See carefully. So in LHS, if I multiply 2 inside, 2 sine square C by 2 plus C into 2 sine square A by 2. Correct? And I can write 2 sine square theta by 2 as 1 minus cos C plus C into 1 minus cos A. Now I don't want cos A and cos C. I need to convert angles to rule here. If I open the bracket, I'll get A minus A cos C plus C minus C cos A. That means A minus A in place of cos C. I can write A square plus B square minus C square upon 2AB plus C into C minus C into in place of cos A. I can write C square plus B square minus A square upon 2BC. Here A will get cancelled, here C will get cancelled. So I'll be left with, I'll separate this A plus C. Correct? I'll take minus common. Denominator is 2B. So A square minus C square plus B square plus C square minus A square. So A square got cancelled, C square got cancelled. I am left with A plus C minus 2B square upon 2B. So here 2 cancelled, BB cancelled. I'll get rearranging A minus B plus C, which is equal to RHS. Hence proved. Now, here let me tell you one interesting thing. If you are paying attention, what should have you told, right? You should have told, sir, I see A cos C here. Do you remember the format? A cos C, C cos A. See, it is the hint of using projection rule. So if A plus C, I'll group it together, I'll take minus common. If I write A cos C plus C cos A, what is A cos C plus C cos A? It is B. So which is equal to RHS. I would have got my answer here in 2 steps instead of doing all this. If just I clicked projection rule. So that only I was going to say, or I was trying to say, it is not necessary to know projection rule for answer. But for speed purposes, we must know projection rule. As you can see, we wasted our time here in calculations in this part. But if we know projection rule, in 2 step mein answer aa jata. No issues. I just first time I also couldn't click I can use projection rule, but after many practices, I could say, yeah, I can use projection rule here. Let's move on to the next question. Here, again a good question. It is a mixture of AP. Now I want you to try this question. Till then, I'll go and drink some water. I'm very thirsty. Okay. You go through the question. approach. Done. So again, what does AP means? AP means twice the middle term is equal to sum of last or third term. Got it? Oh, so it is cot, sorry, cot C. Here what I see is, listen very carefully, I have angles and I need A square, B square, C square, means I need sides. So I need to convert angles to sides. That means I can use both sine rule as well as cosine rule. The problem is here I have cot. So I don't know anything about cot. So let's convert cot into sine and cos. Very simple. I can easily write it as cos B upon sine B is equals to cos A upon sine A plus cos C upon sine C. So now use sine rule and cosine rule both. So if I use cosine rule here, what is cos B? Square plus C square minus B square upon 2AC upon what is sine B? It is K into B is equals to cos A. Cos A is B square plus C square minus A square upon 2BC upon sine is K plus cos A is A square plus B square minus C square upon 2AB upon sine C is K. Now, all the denominator will go up and multiply with here. So what I'll get is, I'll get 2A square plus C square minus B square upon 2K ABC is equals to, here if you can see, 2K ABC will be the LCM and upar I'll get B square plus C square minus A square plus A square plus B square minus C square. So C square got cancelled, A square got cancelled. And from both the sides, 2K ABC also got cancelled. Now, on LHS, if I open the bracket, I'll get 2A square. Two is also going to get cut. Wait, A square plus C square minus B square is equal to B square plus B square, 2B square. Yes, 2 will get cancelled. So I'll get A square plus C square is equals to B square both side, 2B square. Right now, B square both side, B square plus B square. And what does this mean? Twice the middle term is equals to sum of first and third. That means A square, B square, C square are in AP. Hence proved. Got it? Acha, many of you must be curious ki how these prove that type questions are asked in MCQs. So let me tell you, for this one question, they will remove this part, show that part. Correct? And they will give options like, first, A square, B square, C square are in AP. Second, are in GP. Third, are in HP. And D, none. So these types of questions can easily be asked in MCQ. Obviously, these questions are also asked in MCQ. You can check previous year papers. So this will be the options. These will be the options. So obviously you will see how these questions are asked in MCQ. Got it? Let's move on to the next one. Here it is similar. A cos A equal to B cos B. Prove that triangle is right angle. What does right angle triangle means? One of the angle is 90 degree. And what does isosceles triangle means? Two angles are equal. Now let me tell you one interesting thing. 90 degree and two angles equal means what do we need to prove in terms of angle? Don't forget this. If I want to prove something from this given, I need to prove either one angle 90 degree or two angles same. That means I need to prove in terms of angles. So I don't need sides. I don't need A and B. Basically, I need to convert A and B into angles. What is better than sine rule? I can write it as lambda sine A into cos A is equals to lambda sine B. What happened to this B? Lambda sine B into cos B. Here lambda and lambda will get cancelled. Now see very interesting step. Sine A cos A. They need 2. So I multiply both the sides with 2. 2 sine A cos A is equals to 2 sine B cos B. And what is 2 sine A cos A? It is sine 2A is equals to sine 2B. Now I am done with converting into angles. Now just I need to prove 90 degree or two angles are equal. So I'll take on left hand side, I'll get sine 2A minus sine 2B is equal to 0. What is sine minus sine? It is 2 cos. Addition upon 2 into sine. Subtraction upon 2 equals to 0. So this 2 though will go with 0. It will get cancelled. इसमें से I'll take 2 common from numerator. It will get cancelled out from denominator. So I'll get A plus B into same here sine A minus B is equal to 0. Now two terms ka product is 0. What does this mean? This means cos A plus B equals to 0 or sine A minus B is equals to 0. Cos A plus B equals 0. That means I can say that A plus B is equals to pi by 2 or A minus B equals to 0. A minus B equals to 0 means A equals to B. That means triangle is isosceles. Got it? Now, A plus B is pi by 2. We know that A plus B plus C equals to pi. That means pi by 2 plus C equals to pi. That C equals to pi by 2 implies triangle is right angle or triangle is isosceles. I proved both. Triangle is right angle means one angle is 90 degree or two angles are equal. Got it? I hope you got it. How did we prove this? Right? So let's move on to the next question. This one. Again, similar type. What do we have here? We are given this and we need to prove A, B, C are in AP. Now again the same thing. We are given in terms of sides and angles. Don't forget. We want ABC means I don't want angles. Again, what is the problem with angles? The angles are half angles, C by 2 and A by 2. But sine rule and cosine rule में half angles नहीं है. हम लोगों को क्या चाहिए? Full angles. So हम लोग वही फॉर्मूला यूज करेंगे. कौन सा? 1 plus cos theta is 2 cos square theta by 2. That means cos to 1 plus cos theta upon 2. So let's substitute this here. So I'll get A into 1 plus cos C upon 2 plus C into 1 plus cos A upon 2 is equal to 3B by 2. This 2 will become LCM and get cancelled. Now, I can use cosine rule. I can write it as A plus A cos C plus C plus C cos A is equals to 3B. So if I use cosine rule, I'll get A plus A. Acha, I guess you clicked something. Don't you think of saying something here? Chalo, I'll give you 30 seconds to think about. After this equation, what should I do? Come on, guys. It is a very big hint from my side. I stopped using cosine rule because we got this situation somewhere in the previous term and we did it by the lengthy way. So what is your opinion? You can see A cos C, C cos A. So that means this is a hint of using projection rule. I can combine it. I can write A plus C plus A cos C plus C cos A is equals to 3B. So students, I can write A plus C plus B is equals to 3B. See how many steps we have skipped or avoided, not skipped. A plus C equals to 2B. Twice the middle term equals to sum of first and third. That means A, B, C are in AP. Hence proved. HP hence proved. But it अगेन ये कैसे पूछ सकते हैं वो लोग कि देन को हटा के ऑप्शन डाल देंगे एपी जीपी एचपी एंड नन ऑफ दिस सेम. So let's move on to the next question here. It is also a very nice question, but I'll give you a head start. Let's see what you can think about. Obviously this is an MCQ. Got something? First, तो numerator को simplify करते हैं. I can simplify the numerator. Means open the brackets b cos A plus b cos C upon 2 sin square b by 2. Now again. See the options. Options में A, B, C, D सब options में side चाहिए side. और मेरे पास क्या है अभी? I also have angles. That means I need to convert angles to sides. I can use both cosine rule and sine rule. But let me tell you how to speed up the process. Don't use cosine rule here because again we see the pattern. B cos A, B cos C, B cos A, cos के साथ दूसरा side. This means I can use projection rule. C was A cos B plus B cos A. So from here I can write B cos A as C minus A cos B. Correct? Similarly, we know that A is equals to B cos C plus C cos B. So from here, I can write B cos C as A minus C cos B. So if I substitute these here, B cos A, B cos. What will I get? I'll get C minus A cos B plus A minus C cos B upon 2 sine square B by 2. Here I can group A plus C and I can take minus cos B common. So what I'll get again? A plus C upon 2 sine square B by 2. Now ऊपर से I can take A plus C common. What I'll get? 1 minus cos B upon 2 sine square B by 2. We are very close to the answer. 1 minus cos B. We saw in the previous sum itself. क्या लिख सकते हैं 1 minus cos B को? 2 sine square B by 2 upon 2 sine square B by 2. This will get cancelled and we'll be left with A plus C. So what is the option? A plus C or C plus A, which is option C. Got it? Thumbs up. Okay. I hope it is clear. If yes, we can look at the next question. Now, next question is very interesting. So I'll give you 30 seconds. How many? Only 30 to think about how to proceed with the question. It is a very good question. Huh? You can mark it important. Come on, guys. If you have any suggestions or if you have any ideas what we can do, you can write in the chat box or unmute and say. Sure. 30 seconds. Analyze the question first. See, in options, I have 1, 2, 4 C square. Basically means I have constant and I have a side. I have constant and I have side. I have side. That means I don't want angles. So I'll convert angles to sides. Now, sin A minus B. Sin A minus B cannot be easily converted. First, we need to use the compound angle formula. So sin A minus B. What is sin A minus B? Sin A cos B minus cos A sin B. Correct? Sin A की जगह पे I can write KA and cos B की जगह पे A square plus C square minus B square upon 2AC minus sin B की जगह पे I can write K into B, cos A की जगह पे B square plus C square minus A square upon 2BC. Here A will get cancelled, here B will get cancelled. So I'll get 2C here and I can take K common, right? So I'll get A square plus C square minus B square minus open, so sign change, minus B square minus C square plus A square. So C square is getting cancelled. What I'll get? K into A square plus A square. So 2A square minus 2B square upon 2C. I can take 2 common. So I'll get K into A square minus B square upon C. Now, look at this. Sin A plus B. Don't open sin A cos B plus cos A sin B. No, no, no. We are in a triangle, remember. So in triangle, A plus B plus C is pi. That means A plus B ko I can write pi minus C. I want sin A plus B. I can write sin A plus B as sin pi minus C. And what is sin pi minus C? It is sin C. Simple as that. And I can write sin C as, what I can write sin C as? K into C. So now, with these substitutions, sin A minus B, so I can write this sin A plus B. So I can write KC. Let's substitute and look what we'll get. So I'll get, I was telling you sine A plus B, because sine A cos B plus cos A, don't use compound angles. That was I was telling. Chalo, let's look. 2c will be equal to 2c square into k into a square minus b square upon c upon a square minus b square. So here 1c will get cancelled. I get 2kc a square minus b square upon kc a square minus b square, and you got your answer. Kc a square and b square cancel. I'll get 2. This is my answer, option B. So question for today. So before ending the lecture, let's recap what we have done till now. And you can look at the questions also. Whichever question you want me to stop or at the slide, you can go through. So let's fully concentrate on the slide and remove all the distractions. We are going to revise or recap. We studied sine rule, cosine rule, projection rule. I'll move the slide to next. If you want some specific slide, then you can say to me which slide do you want. Chalo. First, we studied sine rule. How to use sine rule? Angles to sides, sides to angles. After that, we saw questions. Very simple questions. After this, we saw the cosine rule. What was cosine rule? Angles to sides. This form we rarely use. As you can see, we have never used this form in any of the questions. Third one. The questions. Then we studied projection rule. प्रोजेक्शन रूल में क्या याद रखना है? मेनली हम लोग को पैटर्न याद रखना है. A cos B, B cos A, B cos C, C cos B, A cos B, B cos A. ये था. Got it? प्रोजेक्शन रूल हेल्प्स अस. क्या करता है हेल्प अपने को? स्पीड बढ़ाने में. And then we saw questions and questions and questions. Many of the questions were prove that types. Many of them were from NCERT and some of them were also from JEE. The prove that questions were from NCERT. Right? So if you now want any slide to go through again, any question to go through, you can tell me, or we'll just end the session. Okay, no, you understood everything? Very good. We saw some good questions. This was a nice one. And this last question. Got it? So if not, let's end the lecture. It was good to have you all. Tomorrow we'll be continuing with the rest of the 3 that were half angle formula, Heron's formula, and Napier's analogy. And then we'll be completing solution of triangles. Till then, bye bye. Take care.